The focus of this class is on kinematics and really the fundamentals of those, looking at links and joints. How do those come together to form linkages, and how to identify different types of links and joints, and ultimately look at the mobility of a mechanism when I start to put these together. So let me first of all take a step back and look at where we had left off last time, defining a mechanism as simply a mechanical device for transferring force and or motion from an input to an output. That's where we left off. Now, I can do that with lots of different mechanisms, and the focus of this class is on linkage mechanisms, so on the left here. But recognize that I just as easily could use a cam, I could use gears, I could use lots of other ways of transferring force and or motion mechanically. Now, what is a linkage? Well, a linkage is simply rigid links connected by joints to form what we call kinematic chains. Now, these kinematic chains can be either open chains or closed chains. So an open chain would be something like my arm here, where I happen to have a shoulder, which is a joint, I have an elbow, which is a joint, a wrist, which is a joint, and all of these form a chain, but this is an open chain because it's not brought back to ground. Now, in other situations, we will have the linkage coming back to ground, in other words, a loop, and that would be considered a closed chain. So I have rigid links connected by joints. So what are links and joints? Well, that's where we're going. But before we get there, let me just add a caution here, and that is that all linkages are not mechanisms. Well, what do I mean by that? Well, imagine that I happen to have now a closed kinematic chain that looks something like this. So I've got, so far, a two-link mechanism. I've got ground as one, and then another link as two, and then I bring this back to ground. So I'm closing this chain, and I've happened to create what we call a structure. So I've got ground as link 1, link 2, link 3, and back to ground as link 1. So I have a 3-bar mechanism. This is a truss structure, and it's not mobile. Now, to make this mobile, I need to add another link. So I could go to a 4-bar mechanism and have something like this. And now, again, a closed kinematic chain, but because I've added this extra link, now you can imagine, all right, I can take this link, rotate it this way. As I do so, it will cause this other link pinned on ground to rotate in that direction. So this is now a mechanism. So just be careful that a linkage can be either mobile or it can be a structure. So we have to pay attention to that. Now, let me bring this back to a more concrete example that we can think about, not just abstract drawings. So I have a 5-year-old son who loves mechanical devices such as this skid steer that I was lucky to borrow from him. And this happens to be just a small model of a skid steer, but it shows the full motion of it. So you can see that I get the lifting mechanism here. And it's not just a simple pivoting mechanism, but there's actually some more complexity to it. And then I get the dumping of the bucket here as well. So what I want to do is I want to create a kinematic drawing or use the general language of kinematics to describe this linkage mechanism. So let me now look at this drawing here and start to overlay what my skeleton drawing would be. Now a skeleton drawing is really just, paring this down to the most basic structure that I have. So I'm going to start with my ground pivot. So I've got one ground pivot right here. You'll notice that I'm calling the frame of this vehicle ground. So I've got a ground pivot right there. I've got another one right here, and you might say, well, what is that for? That is for this hydraulic cylinder right here. So I have a hydraulic cylinder which connects to that pivot right there. And in that cylinder, then I have a piston, and that piston then is connected up to this point right here on the arm. I then have another ground pivot right here. So I've got these 3 ground pivots. And now let me connect this up to this larger moving arm. I've got one link right here. I've got another link that I had the other ground pivot of, so let me connect that down here. So those are the main connections to the lifting function of the skid steer, this lifting part right here. So we can get that motion. Now let's get out to the bucket and do the tipping. So the main pivot on the bucket is this one right down here. And then I have another pivot right up here, which then holds another cylinder that's kind of hidden right here. So this is the second hydraulic cylinder, and that is connected right here. And then the piston of it would be here, connecting out to that pivot right there. And let me finish this off to actually show what these links look like. I'm going to just kind of sketch what the bucket looks like, get out to the tip here, and come back. There's my very crude bucket, but hopefully you get the idea. And then I'm going to connect all of these other dots right here. And as I do so, let's see if I can make this look decent. I'll connect these. And now I can shade all of this in. And as I shade it in, we start to identify exactly what type of a mechanism this is. So let me go ahead and hide the skid steer that was helping me create this. So again, this was just my backdrop, and I'm dropping down to purely the kinematic or the skeleton diagram of this now. I realize it looks like a 2-year-old's drawing, but a little crude. Hopefully you get the basic idea. Now, to make this a complete drawing or a skeleton diagram, we now need to label all of our links and joints. Now, the way that we label these is for every link, we give it a number. For every joint, we give it a letter. So we always start with ground as link 1. So I've got 3 connections of ground here, 1. And then I can start really arbitrarily and move around the rest of my mechanism. So I'll say this is link 2, this big coupler up here, link 3, maybe link 4 over here, link 5 being this side of my cylinder, link 6 being that side of my cylinder, link 7, the side of the bucket cylinder, link 8, the piston side of the bucket cylinder, and link 9 being the bucket itself. So I have a 9-bar mechanism in this case. Now I said I'm going to start labeling all my joints as well, and really I can start anywhere I want to. I'm going to kind of follow the same the things that I did for numbering. So I'm going to call this A. I'm going to call this joint up here B, and then I have C, D, E, F is going to be the sliding joint between the two of them, and then I have G, this other pin joint, H, I have I for the next slider, J, and finally K. So now I have a complete skeleton diagram or drawing of my skid steer mechanism. Now, the other thing I want you to do is start identifying different types of links. So normally we identify links by how many joints they have on them. So a binary link has 2 joints on it. So in this case, I have quite a few binary links. Link, in this case, link 2 would be, let's see if I can get my laser pointer to move. Link 2 would be a binary link, as would be link 4, link 5, link 6, link 7, link 8, and link 9. Those all have 2 connections on them. Now, ternary links have 3 joints on them, and the ground or the frame of the vehicle in this case has 3 ground connection points. I've got 1 here, I've got 2 at the bottom of my cylinder, and 3 out here. So I've got 3 connections. That's a ternary link. Even though I haven't sketched it that way, I've got those 3 ground connections. And then link 3, the big part of the arm here, I've got 5 connections to that. So that would be a pentagonal link. So again, just based on how many connections or how many joints I have on a link, that is how we label that type of a link. Fairly simple. Now let's talk about some different joint types as well. So here we've already found pin joints as well as slider joints. We have lots of other joints as well. So here are some of the more common ones that you'll come across. And what I'm going to do is I'm going to draw how we can represent these with a skeleton diagram. So a pin joint, if I happen to have this connected to ground, I have it just like I had connected before, where I've got a pin and then my line coming out. Now if this happens to be a moving element, I would have a link coming in here, a second link coming out, and then the joint between the 2 of them. For a slider, if we're looking at a slider on ground, this usually looks just like a box, and then I have ground below it, show that it's grounded, and then I'm assuming that's just able to slide and not going to lift off. So there's an assumption built into this that I couldn't lift the block off the plane that it's sliding on. Now you'll also see these sometimes sliding in something else like the hydraulic cylinders, and in this case we would then have the hydraulic cylinder with then a block inside of it and something like that. So now I have that moving slide instead of just the grounded slide. We also have screws, and a screw, we are linking both the translation and the rotation of an element. So this is getting into a 3-dimensional motion, or no longer planar. I also have roll-slide connections, and these are planar joints. And where I have roll-slide connections can be kind of a variety of places. You can imagine something like a wheel on ground, where it could either slide along or it could roll. A very common other one that we would see in, let's see if I can make a little bit better drawing there. See, in a moving application would be what we're calling a fork joint, where I've basically got a pin inside of a slot, and this pin then is connected to something else, so it's able to translate back and forth, as well as rotate about its main axis. So I have a rolling and a sliding connection there. Now we can also move into other types of joints like cylindrical joints where I'm allowing rotation and translation. I can look at spherical joints such as a shoulder joint where I'm allowing 3 degrees of rotation up there. I can look at a planar joint or basically 2 surfaces touching each other where I can get X, Y, and rotation. And one thing that you'll note is I'm starting to talk about what degrees of freedom we allow or restrict with each one of these joints. And so what we often talk about here with these joints is how many degrees of freedom we allow or restrict. So let me just make a little column here of degrees of freedom that we're going to remove. And first of all, if I look at a pin joint, I'm going to be removing 2 of 3. Now, why 3? I'm assuming this is a planar mechanism, so I can move X, Y, and rotate. And by placing a pin on that, I'm removing 2 of the degrees of freedom, the X, Y, and I can only rotate about that point. Similar for the slider joint, I'm going to remove 2 of 3 degrees of freedom because now I'm only allowing translation in one direction. I'm removing the Y and the rotation. When I move to the helix, now I'm again restricting this to 2 of 3. Oh, let me put that up by the helix. 2 of 3. The roll slide connection, I'm allowing 1 of 3, meaning that I'm able to, or I'm restricting, removing 1 degree. I cannot move in the Y direction, but I can move in the X direction as well as rotate. When we get into these last 3 joints, now we're looking at 6 degrees of freedom, the full 3 dimensions. And my cylindrical joint removes 4 of those degrees of freedom, 4 of 6. My spherical joint removes 3, the X, Y, and Z, but it allows 3 rotations. And my planar joint restricts all 3 rotation, or I'm sorry, it restricts 3 of the 6 as well, where I allow 1 rotation and X, Y, so it allows 3 degrees of freedom. So kind of in summary with this quick video lecture, we've talked about, first of all, different link types, how we can put those together into a skeleton diagram, and then different types of joints. We're going to now build on this in the next video lecture and talk about the mobility of a mechanism.